Okay, good afternoon, everyone. So thank you for coming back after this great lunch. So it's time to start the next session of the meeting. So let me go to the session. Okay, this session is related to data, and specifically to data management and data analysis. So more closer. So we are in the era of data, and more we are experiencing the opportunity to have access to instruments that generate information that can tell us to tackle biology at multiple scales. But once that we generate the data has no meaning if we don't analyze it. But for analyze the data, we have to take the data out of the instruments, and we need also to have the possibility to analyze the data and to distribute the data and to get meaning out of it. So in this session, we will have 4 speakers, which will go through the ecosystem of data science. So we will start in the part of data management. And we will also go through another important aspect of bioimaging, which is medical imaging, which is connected to the information that is collected at different scales. Okay, so first I would love to introduce to Dr. Steffen Hartel, which will tell us about the Sistema de Almacenamiento y Servicios Informáticos, Biomédicos, Avanzados, representing Chile. Thank you so much.
Yeah, thank you very much for the introduction, organizers and sponsors for having me here. So I will take some questions that I was informed to answer during my talk. And these are very structured questions in relation to how we work with data, how we put the data into context, and how data plus a context finally gives us information, and we want information. So how we do address specific challenges of data management in the context of our region, what best practices can be adopted by data management bioimaging, provide example of successful collaborations and future developments. These are structured, ordered, and I will respond to that in our dirty, growing, context-driven way to approach data in biomedical and also medical sciences. So I prepared an introduction where is the context, and I do investigation in Chile for the last 22 or 25 years, so already a lot of time. In Chile now we have 50 optical and electron microscopes sponsored by our national funding agency, the FONDEKIP projects. Last time, 2 years ago, we had 45, I checked that, now we have 50. So a reasonable size, 34 in Santiago, which is 60% of all equipment is still in Santiago. So it rains where it's already wet. And these 50 microscopes produce a lot of data. So we need storing. These microscopes, if they are digital, they are open to image processing analysis, so we need computing. Open and interdisciplinary science requires sharing. So I will go through these 3 points and use some and present some use cases from our environment in biomedical and medical imaging. So I will start from the last point, sharing. In Chile, most of us scientists are connected to REUNA, not all of us, which is a research and education network in Chile with connects, with different speeds, different organizations, different entities in or along or across Chile. And we are grateful that Chile has the clearest skies, that we have astronomy, that astronomy is really a big issue, and they produce images and they have to flow, be analyzed. So the astronomers are our best rich friends. Yeah, so this is basically the reason, because we have a really good internet along the country. And the last big success, I would say, was to connect Punta Arenas and extreme south, no, to high-speed network, and we are going to across Ushuaia, Puerto Williams now, no, with high-speed network. So the network is done, basically, not always working nice, but done. Chile is connected. Reuna is in synchrony with Red Clara, which is connecting all of us, Colombia, Costa Rica, Chile, Ecuador, Guatemala, Mexico, Uruguay. So our teleconferences and our networks work reasonably well, I would say, so check. And finally, with Europe and America, US, I think all of us experience pretty nice connection when it comes to speed of data transfer in general. So this is not a huge subject anymore. It becomes more complicated on some local scales. So this is Santiago here. Can you see it? Santiago, big Santiago, says 7 million people. In the Faculty of Medicine, where our laboratory is, we are connected via a high-speed connection to Reuna, 10 gigabytes, and also to the National Laboratory of Supercomputing. No? So we are connected with the major infrastructure, so that's good. But we produce a lot of data, so we need our own data center. It's called SASIBA, the Data Ninja, and I will talk about that. But principally, it's working well. We have problems, however, inside the Faculty of Medicine. No? So we do nice teaching with Magallanes, no? It's the extreme south, but sometimes within our campus, there are parts that are not connected. No? So I get much of crossfire inside the Faculty of Medicine, and we are very successful in other places. So it's fractal. Okay, but the technique is there, and we managed to do that. So check. Yeah, we are connected, we can share. Next, now the Data Ninja. There was a first project in 2014 until 2021. Was the first project that we acquired with 250 terabyte. This was the time where we built and implemented our first 4-lens light sheet microscope. So we produced terabytes of data. So we were already in that league where astronomy plays. That project supported 26 projects, scientific projects and applicated projects, over 300 cloud users, 95% of use, and 99.996 uptime. So this was really successful from the user side. And from 2021, Mauricio Cerda, which is known to some of you, an engineer, computer engineer, took over and brought another grant because the terabytes were filling up. So we were lucky to have another grant, and now we are on the range of 600 terabytes on 3 servers. We have GPU for some artificial intelligence processes, which is also important sometimes to have them very close to where the data is, no? So the communication flows. We have software of multi-mode management, software for biobank, and software for scientific repositories, no? And this was the sketch that we posted, and we were awarded. So there's a biobank, there's clinical studies also, so we were more closely to the medical field. Image processing, ER, that's what already been talking about in the morning. Yeah, and finally, research and development in biomedicine in Chile, data connected to other nodes also, no? That Catholic University, load in medicine, at engineering faculty, because that's where the supercomputer is. No, but they didn't have the storing capacities at that time. Yeah, no, so that was our selling point. Okay, so this is working now. And you can go and see it at the web page, which kind of services do we offer. There are cloud service, there are servers also to servers that do medical research. And this was important for us because the clinics need security. They need to be sure that the patient data is in hands that they can trust. And a lot of these investigations in more the medical field are built on trust, no? The famous trust, and trust is built step by step. So we say we have the data center at home, secure, tier 4, trust us, no? And so far we are doing fine, and they accept our propositions to do medical research. So this was I don't want to be too technical, but because everybody here has this data creating microscopy environment, no? They need to be stored in fast or slow components, and they have to become accessible to the users, researchers, education, research platforms, or clinical users. And we know that they have very different skills of how to handle the access to quantitative data. No? Physicians, medical doctors need to press a button, and there needs to be information. And press the button sometimes is already a lot, no, for them. Meanwhile, physics and engineering people can write a code, a line, and they can program. No? So we have to be really user sensitive. It becomes more critical when we come to the medical field because that anonymization or pseudo-anonymization problem that needs to be solved. It's not hard to solve it, but it must be solved. We need to address issues of interoperability. No? In medical field, that is solved in theory, but not in practice. No? The HL7 fire components are not well established along our country, but they exist, and so we need dichomizer sometimes to get formats that are not in DICOM format to the PAC system, or we just build custom specific solutions. No, because every microscope is getting another type of data, so we can be flexible for what each user needs. Again, these are the users. Okay, so done. Storage enough for the moment, and that is our working philosophy. Now it comes to computing. We are connected, as I said, well to the National Laboratory for High Performance Computing, big machine, more for the astronomers. But since it is more built on CPUs and we are more with deep learning, with artificial intelligence, we need GPUs. No? So we have built intermediate structure in our laboratory, some graphical cards with a lot of storage for laboratory equipment. Or in SASIBA, we have some GPUs to build algorithms and train algorithms in the data server, in the data center, sorry. And we are connected also to regional centers like the Patagon, which is in Valdivia. No? And this is a trick. Sometimes infrastructure goes to regions, but there are not enough researchers in regions to use the infrastructure. Happens. No? So we are happy friends, happy users of their infrastructure and collaborating. No? So this has been great for us. So tick, 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 we're done. How much time do I have? Yeah, 5 minutes? 7 minutes, okay. So let's go to the use cases. But again, summarizing, I would say we are more or less reasonably connected with a reasonable storage, with reasonable computing power in different scales. Yeah, use cases. One case of a postdoc, Jorge Jara, he is from engineering, and he is focused on getting the best shapes on, this is a movie, but the PDF is not working, to get the best shape of cells that are in developmental biology evolving inside, let's say, a fish brain. No? So he faces a challenge to really find the triple points, to really find adjacent contours and get everything shaped to respect the shape of each individual cell, but also about of the organ. So this is a lot of geometry-based computing. And now he's working also, of course, with artificial intelligence and training, and see how that can improve the outcome. So he is basically storing his data. I will not go into the scientific part. Storing his data on our data center, working, training in our lab computer, but then doing the real world in southern Chile in Valdivia. No? That's how he's organizing. Yeah, because we don't have the optimal conditions in one place, no? But we can share. Use case 1. Use case 2, more to the medical side, when Corona struck us and a little before, and the microscopy facility was shut, we moved to the hospital, no? Because there was a pressure from the hospital and the radiologist to decide is a patient COVID or pneumonia, no? So we put a project together for 1 year, and we were really happy with the results because we could distinguish very well ground glass opacities from condensation and give quantitative data to the radiologist to decide what is happening with the patient in the lung, because they were working under a lot of pressure. But Corona was short. No? So we didn't implement it in the hospital, mainly because AGFA, who was our provider of the PAC system, wasn't able to put a button on the screen. No? And the physicians in stress didn't want to use two systems, one to see the normal procedure and another to see the results of a quantitative analysis. No? Then Corona was over, but we had a beautiful system. I will not talk about pathology now. Similar, we have a project on pathology. It worked beautifully for the deep learning algorithms to detect different types of cancer. Now I have 3 minutes. But the workflow to install digital pathology in our reality is a mess still. No, technology fine, workflow bad. No, that would be what we learned. So now we with all that knowledge, we swifted to cancer, and there are beautiful results now coming out of detection of cancer lesions in patients with different kind of treatments. We do resist analysis and support how cancers grow, are detected, and support again physicians with quantitative data. But it works very nice. We are on that right now, and we got to the point that the radiologist time to give us the ground truth information is the bottleneck. So we are training now the system with international databases for a first model, and then we perform iterative improvement cycles. And that is fast, and that is finally giving good results for the outcomes. Okay, how do we work there? We train in our lab, and then do the final results in the data center with not so much GPUs. No? Basically because Amazon is very expensive, and that is more cheap for us. Or almost last use case, we were in the pandemics very successful with digital support for histology glasses, but we worked a lot to provide everyone who needed with basic material. So we didn't do studies. How does that really improve the learning process? No? And after the pandemics, we did the studies and we published and quantified how people learn here with digital material. Because there's a lot of resistance also. Oh, digital is not so good as the real microscope. People need to touch the sample, and so it goes on and on and on. Okay, we tried it. Here's the data. Next. That's our equation. We don't know if that works. Yeah. Well, the project I wanted to close is a regional project where we successfully have a grant now to build a network in digital health, not so much imaging. Imaging is a sidekick, but at least it's the first network of state universities in this context along the country to produce good practices and disseminate standards more in the digital health field. No? So we visited the people, so it's about people. We visited all 14 universities. Had the last meeting the week before in Chillán. What is important here, we have two products. One product for mental health support of our students, because mental health of our students is a real big issue. And the other is a register for the students at the health center that attend students. Most of the universities were working with paper. So we have the offer to digitize that now, and the student patient IDs, the directory, will be hosted at our data center. No? So this is an additional server, because we also have to survive. And it's very difficult to survive with the fees that biomedical researchers, that are willing to pay for the data center. No? So the sidekick is the medical field, and they are more used to pay services. Yeah. Okay, so this is the last showcase or use case that I wanted to show. What are we doing? We keep training, as all of you, as many students as possible. No? After Corona, we stopped that. Presence courses, you came back to the present courses. So did we. I want to mention one that we do with Uruguay. with biofilms, microscopy and biofilms. So we learned that this is important to address on specific scientific fields and bring knowledge about microscopy to specific biologic fields. No? And we really were surprised how little the microbiologists knew about microscopy. So there's a huge gap to fill in the future. No? And the course was nice because we had a theoretical session for students from Chile and Uruguay, but then we had a practical session in Uruguay, and weeks later a practical session in Chile. So we had the virtual experience, but also the hands-on experience, and people traveled. No? We did that once with the Pasteur Institute also, but kept not doing that anymore because it's expensive and it's a lot of organizational pressure to do that, but finally we came back to that. Yeah, we're doing courses of microscopy forces development also. Many Latin American students, we were able to invite and pay some part of their stay. And since we are close to astronomy, we do workshops. And Mauricio said us now at I think the 7th version of La Serena Data School for astronomy. And we put biology into that to also have a use case for biology. And of course, the data is run in our data server. And I'm done. Yeah, tonight I have the excuse that because we are teaching our course in image processing, so I will not be with you from 6 to midnight, but that's how we live. And finally, yeah, we are organizing as much as we do. With Veronica, we built a symposium on imaging in last year's event in the Biological Society for Cell Biology. We said we would have a meeting this 15th of November in Chile, in Valdivia. Some of you in the morning talked about Valdivia, to have the kickoff of our Chilean Society of Imaging Science. So there we come together and really say what we want to do as a society in Chile, because we haven't been organized so far very well from the scientific point of view. So please be aware of that. And we are almost done, I would say, with 50 pages of agreements and stuff, which helps us organize like a society in real life. And that's what I wanted to share. With the questions, we can leave that for the discussion, maybe. And thank you very much, and still a lot to do. And yeah, we are in growth. Thank you.